All right. Now we're really living dangerously.
Yep.
Okay, well, thank you everybody for joining us today for the October or September, right?
Still
I'm
a
so
thing.
used to like thinking ahead for different RGovies things or school or whatever. So anyway, so it's hard for me to remember what month it is. It's September still, at least for a few more days. Anyway, welcome to the September RGovies event. I'm super happy to have Jared Lander here with us today. I've known Jared for gosh, several years, right? Maybe 4 or 5 years.
Roughly.
Yeah,
Yeah.
but I don't think we've ever met in person.
Oh, you're right.
Um, because all the things we've done together have been virtually through
Hmm.
conferences and that type of thing. Anyway, Jared will introduce himself, but he has done a lot of work for the advancing our community, especially in government applications and advancements. So I'll let you say what your topic is when you start. Um, Jared did say that he is willing to answer questions as we go. So if you have questions, put them in the Q&A or the chat. I'll kind of monitor both. And if it seems like it's something, that I could interrupt Jared to ask, then we'll do that.
Mhm.
And if the question is like maybe too complicated or maybe later on, it's a good point for a discussion. I think I can unmute you. I think I can do that.
Mhm.
And then you'll be able to, chime in verbally. Okay, so without further ado, I am going to let Jared take over and give us a talk on deploying R in a secure environment. If I got that right.
Great. Well,
All
thank,
right, thanks, Jared.
thank you, Wendy, and thank you for having me. Hi, everyone. I'm Jared. Just a very quick bio about me. I own a company called Lander Analytics, named after me. And we are a data science, AI, machine learning advisory consulting company. Part of what we do is make sure companies and agencies can use R, and that's a lot of what this talk's going to be. We also just help companies with their analysis or building algorithms or automating processes, building dashboards. So, if you're looking for any consultants, we're available. I have to give you a sales pitch. As an owner of a company, I'm always selling. And today's talk, which I'll fire up in a second, is about deploying, well, not fired up right now, it's deploying R in secure environments as you might come across in the government. If you want to learn more about me, by the way, I did keep my full bio because I don't think anyone wants it. You can go to jaredlander.com. That has most of my personal stuff, or landeranalytics.com to learn more about my company. So let me share my screen and we can get going. Once I get that going. Here you go. All right. So you should be able to see my slideshow. I hope everyone can see.
I can see it. It looks good.
Wonderful. Thank you very much.
Uh-huh.
So this talk is about putting R and friends, just like a lot of these meetup groups, conferences I run. It's about R and other languages too, can sneak in there. But how we put them into production in a secure environment. And of course, secure means different things to different people. So I will address sort of what secure means in what context. Now, the first time I gave this talk was a few years ago at the R Government Conference, and some things have changed since then, or at least my knowledge has changed at least, and I'll try to point that out as I go. So, first up, we have to define what are we deploying, what is going into production, and what do we mean secure? But what are we deploying first of all? Well, in this case, it's giving people the ability to use R or Python or maybe Julia in these environments that are highly locked down, as well as the packages you might need, because R by itself is great, but you want all the add-on packages. You want data table or dplyr. You want ggplot or a lattice. You want DBI. So it's how do you get all those extra packages? But beyond just giving people the ability to use their languages, we want to give people the ability to use a code editor, such as RStudio or Jupyter or VS Code. And if you use Posit Workbench, you could use all three. So our goal here isn't so much necessarily to, in this talk, isn't to deploy applications or algorithms that we wrote into production, is to give people the ability to use R and other languages in production in their environments. And I mentioned briefly before that you need a place to have add-on packages. We'll talk about now this is out of date, but RStudio Package Manager. Now it's Posit Package Manager, but a way to host packages in your secure environment, assuming that your secure environment can't just reach out to CRAN or to GitHub. Maybe you want PyPy, or maybe you want GitHub packages or Linux packages from apt and rel. And another focus, and is just based on my experience and my business, is RStudio Connect. I assume most of you know about Connect. It's a publishing platform. It lets you publish documents and Shiny apps. You could host Jupyter notebooks. We're going to focus here on the Posit tools, Workbench, Package Manager, Connect, but it's similar for Jupyter Lab or Shiny Proxy or VS Code. So first up, where are we deploying R and Friends? So what type of environments are we deploying on? Well, if we're lucky, we get to install on bare metal. This is great when they actually give us an actual physical machine that we can install the software on and get raw performance. So this is very rare. We see very few customers actually do that. Far more common is an on-premises VM. Whether they're using VMware or VirtualBox or Hyper-V, having an on-prem VM is probably the most, used to be the most common use case. Now it's probably second most. But it's very nice working in the VM world, because if you ever want to have a bigger machine, they could just resize it. Or if we're going to make an update on the software, they can image the machine in case there's a regression, and they can put the machine back to the way it was an hour ago. So that's really nice. But even more common is a cloud provider and a VM in that cloud provider. Let's be honest, it's mostly AWS or Azure, though I do love DigitalOcean. If you don't know it, it's a smaller cloud host provider based out of New York with data centers all over the world. I know they have multiple places in the United States. They have India, Singapore, somewhere in Europe. It's all over the place. And it's a really nice company, very easy to work with. And they meet all like the SOC 2 requirements, but you're not going to see it too often in government work. And to be honest, you're really not going to see it too often in Fortune 500 companies either. Now, beyond just VMs, we're often deploying inside of Kubernetes. And Kubernetes is so hot right now. It's usually a managed Kubernetes distribution like EKS or Azure Kubernetes. But to us, Kubernetes is Kubernetes, and we oftentimes will install R, Python, and the Posit stack in a Kubernetes environment. So now that we sort of see the different types of computing environments we might use, we have to ask, well, how locked down are these environments? How accessible are they, both to us to maintain them, but to users who want to code, or users who want to consume the results of the code in Shiny apps, or using Connect for Quarto and Markdown documents? And secure means different things to different people, and certainly to different agencies. At the very bottom of this tower of security is when the environment is exposed to the public internet, that anyone with the URL can access it. You need really good authentication for this, because anyone can come to your website and access your applications. We have seen a few companies want that. One of the main reasons, at least for one of them, was because their executives refused to log onto a VPN when they're on the road or at home. So they needed a public URL that the executives could hit, which means anyone could hit it, which means they need to have good authentication. And that means we needed to have it in writing that was going to be exposed to the internet, because, that is a security risk, and one we rarely see. Much more common is the environment is inside the company or agency's network. That's the left side of this image here. It is this internal network, which you can get to from the outside if you have a VPN. But you have to be within this, I'm going to call it this perimeter, to see it. So if you're just on the regular internet, you can't see this environment. But if you VPN in, you can see it. And it's always some, corporate VPN like Juniper Networks or F5 or Citrix or something. It's never some great open source one like WireGuard. But one of the big important things is that the machines we are installing on, where you're going to put our Workbench or Connect, has outbound internet access. That's really helpful. Then we also get to some companies and agencies where they have air gapping. Now, this is the lesser of an air-gapped environment. On the right side is your air-gapped network that has no internet access. It can't go outside, and it can't bring things in. Nothing from the outside can get in, and it can't even reach out to services outside the network. However, it is connected to a parallel network that has internet access. So you could jump from your disconnected network to a connected network to get to the outside world. And that's common. You'll see that, and we see that at some financial government regulatory bodies that have a air-gapped network like this. Then we get to some defense or intelligence networks where it's completely air-gapped, where the right side of the network has no outbound internet and no inbound, and it's not even connected to another network that does have access. You can't make that jump from one network to another. Now, this is the strictest of the environments that we work in. And our focus for this conversation will be these two versions of air-gapped. The version here you see where there's not even access to a network with internet access, and then the other lighter air-gapped that has access to a connected network. But what organizations are we doing this for? Like, who needs this level of strictness? More than you would think. Banks oftentimes have this air-gapped network, hedge funds, which some people might lump together. Consumer goods, surprisingly, we've worked with a few consumer goods manufacturers that have air-gapped networks because their security really matters to them. Hospitals and pharmaceuticals, that would make sense. Manufacturing, like if you're making these heavy manufacturer, like making metal, you could have some important systems. And of course, government, whether that is financial regulators, pharmaceutical regulators, defense, intelligence, various levels of government, especially dealing with PHI, need to have secure networks, sometimes air-gapped, sometimes not. So you have various degrees of strictness depending on their threat level. So how do these organizations trust us? We're an outside vendor, right? And I guess for some of you, this might be obvious. You know some of these answers, but I'm not sure everyone does. But how these organizations know they could trust us, because we're an outside vendor comprised of individual people. How do they know we're not going to come in there and mess stuff up? If it's for industry, these are private and public companies. They might put us through a background check like Sterling. And this is usually fairly simple. It's essentially like running a credit report and making sure you haven't been arrested. We might take drug tests. I've definitely gone to companies where they made me take a drug test before they let me start working. And they might provide all sorts of training. I have taken repeated cybersecurity training for multiple different customers. And the common thread amongst all of them are that they're really boring. And they're really just common sense stuff that if you work in computers, you know, but they have to check off the box. If you're working in finance, you might take insider trading training. Or you might be taught how to handle PII. Or if you're working with a pharmaceutical or a healthcare organization, PHI. So lots of training, background checks, and drug tests. The government has its own system of background checks, clearances. Now, there's public trust, which technically isn't the clearance, but a lot of people lump in with clearance. And you'll often see public trust, at least what I've seen so far, of financial agencies like the Federal Reserve or Securities and Exchange Commission. I'm sure it's for other agencies as well, but once myself and some employees got public trust, like, oh, we have public trust, we're good for those. And of course, secret, top secret, SCI, maybe SAP programs for other stricter parts. And you might think it's a subset that if you have top secret, well, if you have top secret, you have secret, you're good. But neither top secret nor secret includes public trust. Public trust is a separate program, so we've been cleared, my people, in a combination of these things. Some have just public trust, some have just top secret, some have both. So it's a combination of things. And when we go to commercial customers, they want to do a background check on us. I'm like, the federal government already has done the background check. Is that good enough? Some say yes, some say no. Because it's never as good as their own thing.
Hey, Jared,
Yes.
just to interrupt that, and sometimes you could have a top secret SCI from one agency and, say DoD, and it's not recognized by another agency, non-DoD or not.
Mhm.
So,
And theoretically, I know the Department of Energy, DoD, Department of Justice, and a fourth one are all supposed to like share, like they respect each other's. I guess that's up to collateral. Like up to top secret, they share, but once you get to SCI and SAP, that's when they stop sharing, maybe.
yeah, I know. And I think in the intelligence agencies, it's even worse, but
Then you have to get to passing your clearance. You want to go visit someone at the different facilities. It's a tangled web of paperwork.
yeah,
Yeah, yeah. It does. They don't make it easy.
no.
Yeah, which I guess is the compartmentalization in SCI. And of course, the government, if you're going to hold their clearances, they make you take training too. So more cybersecurity training, insider threat training, which is different than insider trading we saw earlier. They're different. Insider trading is literally if you work at a bank, there's rules about trading in public information. The government has insider threat, which they want to make sure there's no moles. There's a history of that in all secret organizations. And of course, PII training in some government fields, PHI training. And again, some of these trainings are so-so, some are not. But they train us with their training and they investigate us. That's how they know they can trust us. And of course, continuous vetting and maybe keep up on us. So now that we know what organizations, we know the environments, we know that they're going to let us in the door. Well, how do we do our job? How do we access these air-gapped machines? If we're in the type of air-gapped network that has a connection to an internet-facing site, well, then we can often SSH into it through, we can create an SSH tunnel through a bastion. Or we can access their, and this is their internet-facing network. We could have a bastion that lets us into the internet-facing network, or we can use a VPN to get into the internet-facing network, or sometimes they'll give us a virtual desktop in a browser. And once we're into that internal network, then we could jump laterally to their air-gapped network. So while we can't directly go to the air-gapped network, we could jump into the internet-facing network, then from there jump into the air-gapped network. And that is a very common thing we've seen. And this lets us work fully remotely. When we're working, again, this is at some government agencies and corporate customers. We have people at our company working in, I'm trying to think of the states, we have in Oregon, in South Dakota, in Illinois, in New York, in Utah, in Florida, in DC. We have people all over the place, and they're able to do these jobs remotely by jumping through the internet connected side of the network. But if there is no forward-facing internet side of the network, there's no internet to jump through, there's no network we could jump through, well, we need physical access to the network, which is never as much fun looking as this image. Usually means we're sitting in a secure room, often windowless. I'm sure many of you know what I'm talking about. We'll be in these rooms. Some of them have windows and they're very nice, but most of the time we're sitting in a windowless room, which a lot of programmers like, so it's cool. Now, big key difference here, well, there's lots of differences, we can't use our own equipment. For these other network types, we can often, not always, use our own laptops to jump into their forward-facing network. Some of those customers still insist on using their own laptops. And of course, when we're in the physical room, we're not even allowed to bring our laptop in with us. We can't bring a phone or a YubiKey or anything into this room. All right, so now that we're inside that network, whether we're talking about jumping through the internet network or whether we're physically in the room, it's time to deploy. And for this, we are going to make great use of Docker. Everything's going to go in Docker. Every little thing is in Docker. Nothing's going to be outside of Docker. Well, not nothing, some things. So this is going to be our typical stack that we are installing. Posit Workbench, Connect Package Manager, Postgres, Usually not to store the data because the customer has their own data, but this is for the metadata from the POSIT packages, and Nginx for redirecting traffic. And oftentimes there'll be a Linux package manager, or I guess a Linux package repository, like something that apt or yum can reach out to. But oftentimes those things can be in the terabytes, so that's usually done by someone else. So let's go take a look at each of these pieces of software and what's involved. For Workbench to work, we need to install R, optionally Python, and some basic packages that are common in day-to-day usage, and then system libraries. That might be like libxml2, libgit, libgdal-dev. If anyone's ever tried to do anything with a map or anything that does network diagrams, you need GDAL. And GDAL is one of the most painful things I've ever dealt with in my life, and it's cost me literal weeks of my life trying to fix problems with GDAL. But you need that installed nicely. As we install all these Linux packages, and of course you install Workbench itself. Since this is Docker, you need to persist the data. So you need volumes for the home directory of Workbench because every Workbench user gets a /home directory in Linux. And you need a volume for the config files. So that way you can make changes to the setup as needed. And you're going to need to configure items like the authentication provider, connection to the data databases and to the metadata databases. You need to point to your internal package manager, which we'll discuss. And you need to make sure you expose the correct ports. So this way you can make Workbench accessible to the users, assuming all those users are on the network that has access. Connect is similar. You install R, Python, if you want Python, some basic packages, your system libraries, and Connect itself, you install that all into the image. And you mount a volume to hold all the content you're generating and to hold your config files. And once again, you need to configure the authentication provider, your data connection to the databases and to the metadata databases that are needed for Connect, what port it'll be listening to, what URL it will be served from. And since Connect can serve emails, you need an email service you need to configure if you're allowed. There are many, many customers that will not give us the credentials to their SMTP server for security reasons. So then Connect cannot send email because they won't give it to us. Package manager is a little bit easier. You just need R and maybe Python, the system libraries and package manager that all gets installed into the image. And again, when we build these images, we build them on the low side, and then we move them to the high side, which we'll discuss. This needs storage, volume storage for storing all those packages, which could be anywhere from 200 megabytes to 200 gigabytes to multiple terabytes. Sorry, not 200 megabytes, that's tiny. One of the problems with using R and Linux is that when you install a package, you have to compile it. And package manager, oftentimes, when it's installed in a secure environment, people just put the source code of the packages because it takes only 200 gigabytes of storage. That means every time you install dplyr, it could be a 10-minute wait. But if you use package manager to serve binaries, things install in seconds, not minutes. And that's great, but now all of a sudden your storage could blow up to be terabytes. But to be honest, the storage cost is less than the human time of sitting there waiting for the packages to compile. And we need to configure here connections to the metadata database, what port to listen to, access to Git repos if you want to host your own Git packages and have it build automatically. And you need to secure that Git connection. Then we will put Postgres inside of a container, and we'll do one container each for Workbench, the database for Workbench, and the database for Connect, and the database for Package Manager. Those are, you could put them all in one container, but we like having things separate so you can move them around on different machines if you need. And in this container, you pretty much just need to install Postgres, and then create volumes to store the data in Postgres and the configuration. And configuration is pretty easy. You just need to configure the listening port for the most part. And set up a username for package manager to talk with, or connect to Workbench as well. Then Nginx. For those that are not familiar, this is we're using it as a reverse proxy. So this way, instead of having to use a URL, you put in instead of having to use an IP address, you put in a URL and it routes it to the correct stack. You put in rstudio.org and it goes to your organization's RStudio at port 8787 versus connect.org, which goes to POSIT Connect at your IP address colon, I think 3939 or whatever it may be. So here you're mostly configuring the URL routings, what URL goes to what IP, how to escalate security. If someone puts an HTTP, it upgrades to HTTPS, and you need to specify your SSL certificates, which are not fun to deal with. So let's say you successfully built all of your images on the low side and you've tested them and you make them work. Well, you need to make sure they are secure. You need to do scans. Every single image needs to be scanned, whether you're using something like OpenVAS or using Nmap scripts. And there's bound to be CVEs. These are common vulnerabilities and exposures. And you need to report those to the customer. Let them know what there is, what's critical, what's not critical, what can be patched. And you have to identify what you can change. Now, we do our own scanning because we believe in providing good images to the customer. But sometimes our customers will do their own layer of scanning on top of this, which gives an extra layer of feeling good about this. So I want to make sure these things are secure. So once we've done the scan, we've got to make sure they are secure. We've got to take our lessons from the scanning to make sure that they are hardened before we even give it to the customer for their scanning. We prefer to not be in a situation where the customer scans and it says, hey, you gave us a bad container. We want it to sail through their scanning with no problems because we want to be a good provider. So hardening most commonly will be removing any unused service. If there's a service in the image that you don't need, why is it in there? Let's get rid of it. We also want to make sure any ports that aren't being used are closed. For instance, Workbench communicates on port 8787. If we don't need port 5432, which is for Postgres, if we don't need that open into Workbench, close it. That should not be open. Don't let things in. And particularly if R, you want to avoid any packages that make internet requests. For instance, the GERT package, which is for interacting with Git. If it's missing a Linux library, it will try to reach out to the internet and install that library for you. Let me tell you, I had a R image on JWix, and GERT tried reaching out to the internet, and everyone gave me a look like, you should be disappointed with yourself. It did not feel good having that shame that I had an internet connecting package. Now, it would have been fine if that Linux library that GERT needed was already installed on our image. But this was a dependency of a dependency. I was trying to use Golem for building Shiny apps. That called use this, and use this called GERT, and GERT had an unmet system library. So now when we install packages, we try to do a dependency chain and figure out what Linux packages are needed. And we try to talk to the customer saying, what R packages are you going to use? And find all the Linux packages they'll need. Arrow, if you don't build it correctly, tries to reach out to the internet at first install. And so does Torch. Torch also tries to reach out to the internet at first install unless you have things ready to go for them. Oh, Wendy, it looked like you unmuted.
Oh, yeah, I was just gonna say that maybe you said it already, but I think JWix is the a top secret network, right?
Actually, JWix is even more, it's SCI.
Okay.
Yeah, so JWix, it's a top secret SCI network. So if you have top secret clearance, that's not good enough. You need to have SCI to touch that to touch that network. So folks, I know a lot of what I'm talking about here is defense related. Just because that's if I figure if it's secure enough for defense, then I can install it on our other government customers. So I use that as my high water mark.
Well, okay, I'll probably get this little story wrong, but when I left sort of a dark agency where we did have JWix, anyway, I went from a SCIF, so secure facility, to the Bureau of Labor Statistics, and it was I mean, they had security considerations just like the Defense Department, and because of protecting the data and the statistics and things. So, and somebody had made a statement like, well, it's not good at the Department of Defense isn't good enough for what the BLS needs.
Yep.
So um, they said they had even higher security requirements or something. So anyway, so the terminology, I think, of course, and acronyms or whatever changes, but still it's similar considerations. And
Yeah.
I don't know, and maybe at the end, if we have we have time, I can tell you how I don't know the details, but I know some of the details, but how they put our sort of we had our own little crayon on
And that's what package managers tries to make easier now.
yeah. Well, this was pre
Package manager.
I mean, maybe our studio was like baby our studio at the time. Anyway, so just I thought I'd throw that in there.
And it's a very good point to give a sense of that. So, like, if JWix is top secret, if some of that stuff leaks, someone might get killed, right? But IRS, we're doing some training for them. They have a database with everyone's financial records going back to 1970. That's incredibly damaging too if that gets leaked, both for the individuals that get leaked, but also damaging to the IRS's reputation as safeguarding our information. So that's incredibly damaging in a completely different way that you cannot let out. And then let's say the Securities and Exchange Commission, they have information about publicly traded companies that might not be released yet. And that gets out, that creates an imbalance in the financial markets. Well, that's insider trading, which is a very big crime. So you can think about how important all these networks are. And even though no one might die from a leak at the Securities and Exchange Commission, crimes can be committed or people's lives can be ruined. So it needs to be incredibly secure, so everyone has their own standards. Though you would think that theoretically NSA is in charge of securing government computers. Well, they're the arbiter of this, what they say goes. But of course, everyone wants to have their own bounds. I know we had a discussion at the interagency R user group a few weeks ago, Wendy organized, and even FDA said that within HHS they can't use things other HHS agencies use because they're not FDA. I think someone said even within one agency, they can't use what a different department in that agency uses. So it's everyone has their own field and their own rules, which are all originally built because something bad happened, you need to protect it, but now it just makes everything harder and more hoops to jump through. So you're always trying to find, and it's all the cybersecurity. You need to make sure it's secure enough, but usable enough.
Those are all really good points. Yes, and you're right about the impact on world markets, the world economies, and then also too there's then if we don't safeguard the data and things get out, then we lose trust in government.
Yep.
So yeah, it's just different consequences, I guess. And
yeah, and if trust in the government's an important thing, like the dollar is backed by the full faith and credit of the United States. You lose faith and credit in the United States because the IRS lets everything out. That's really bad. So we have all these network restrictions we need to meet, and we built these beautiful images, right? We have these images that have everything we need in it, and sometimes you might need to install extra software, which I haven't talked about. We have one customer where they have an air-gapped network, and in order to get out of the network to other parts of their secure network, you need to go through a proxy. And they need to access data that's behind a different proxy. And you can't jump through two proxies natively. So they need to install a piece of software called proxy chains. So you might need to add that into your image. So there's all sorts of customizations that these images might need. It's not enough just to install Workbench and Connect. You need to install other pieces of software that Workbench and Connect might use. You might want to install DuckDB into those images, or you might want to install the H3 library for spatial calculations. So we need to be able to customize these images for different customers. And part of that, actually, this is behind the scenes, we do everything with either GitHub Actions or Bitbucket pipelines. And this way, these images are built in a version controlled system. And if we update an image, install an extra piece of software, it's automatically built and put into a container registry, which is part of what we're going to talk about next. How do we get the images onto these air-gapped machines? So if we have a network where the air-gapped network can talk to an open network, well, similar to how we access it, we go through a jump box and either SCP or rsync the images. Or their network might be able to reach out to a private container registry. For instance, they might have their own registry that we have push on the connected network that we could push, or they might have an opening like a firewall rule in the open internet to Azure Container Registry, or they might have a way to move it over. However, if we don't have access to, if the air gap network has no connection to the internet facing network, well, then we go to the good old sneaker net. This is where, on the internet connected side, we put the image onto a physical hard drive. We unplug that hard drive from the network, fill out paperwork, and get a lot of signatures, and run it over to the air gap network, plug it in, and copy the images over to that computer. Yes, I've seen this. In fact, I've seen them use DVDs for doing this. It's probably what is keeping the DVD industry in business. And I've seen it with physical hard drives that are kept in safes when not in use. Now, some things that are new since I made this talk, I literally just discovered this. For certain military networks, I discovered a service ran by one of the agencies that if you provide them with a Docker registry, such as Docker Hub, GitHub registry, Azure registry, Google registry, or any of them, they will automatically move it from that low side registry, even if it's a password protected, scan it, and move it up into the top secret network. At first, I was super excited about this. I'm like, this is too good to be true because I don't need to use a hard drive anymore. So I tested it out with a very beefy image, a 6 GB image. And this is an image that has RStudio. It has every R package I want, the entire Tidyverse, Tidy models, the Tidy time series universe, spatial, LaTeX. I installed Torch. I installed XGBoost, everything you could ever want. And I asked this service to move it to the high side. And I wanted to see how well it will go. It was there 2 hours later. It took 2 hours. That's an incredibly short amount of time. And the best part is, I asked them, so can you update it twice a week? And now twice a week, that image is being pulled up into the high side network. I can't stress how amazing that is. So now all these beautiful images we're making on the low side are available to us on the top secret networks. And it's just magical. So if you're working in an environment that is, a top secret network, these services exist for you to move them like that. And if you're working on a different type of network that allows you to move images, like we're doing one right now for a financial regulator, that we're able to use rsync to move across services. So look what's available to you. When I found out about this service for moving images, no one else at the office I work with heard about this. They were all shocked and like, oh my God, this makes our lives so much better. So before you start going through this crazy dance of, doing the sneaker net, try to find out if there's anything available. And I stumbled upon this by accident. So you might not have a good resource for finding out this information. So see what's around. Now, likewise, we need to move packages, particularly R packages, to these air gap machines. So it's the same idea as the container images. You need to either rsync them, or you need to do a sneaker net, or as we just discovered, at least for these military networks, they have a syncing service which will let you sync a S3 bucket to a high side S3 bucket. I generally don't want to use too many S3 buckets because the cost racks up. It can get really high really fast and want to be conscientious of that. But if that's the easiest thing, that's cheaper than the human cost, and that's valuable. And in this case, this particularly for RStudio, Posit Package Manager, they have an offline syncing service where they will download either the source code for the packages or the binary files. You can download them to the internet connected machine, then you either rsync them to the air gap side, or you put it on a hard drive and move them over. Now, as of the time I wrote this, I don't think PyPy can be synced with an air gap solution. They might have added that since then, but I'm not sure, in which case you could use Artifactory. That's another service which is really used for syncing PyPy very often. And again, similar to moving Docker images, rsync or sneakernet. But all these commercial products need to be activated, whether it's Posit or Artifactory or GitLab. They need some way to phone home to a license server to know that you're allowed to use it. Well, depending on the type of server, you might be able to do offline activation. Where on the air gap machine, it generates some XML that you have to copy and paste into a website, and then they return more XML, which you copy and paste back into the terminal. That assumes that you have the ability to get the XML from the air-gapped computer to the internet computer, other than writing it down with a pen and paper, which really sucks. Another option is a license server. This is like an additional server, additional Docker image on a different machine that it can communicate to the air-gapped network, and it can communicate to the outside world. And the air-gapped network talks to the license server, which talks to the outside world, validates the license, and talks back. Now, of course, this won't work so well in real air-gapped networks. So lastly, that leaves us with activation keys. Some pieces of software give you a file that if you put it in the right place on the server, provides the server information that, yes, this license is valid till this date. And that works great. And that's our primary preferred way. It's the cleanest, and it really works inside Docker. So a lot of these other activation methods, if you activate the image in Docker, then the Docker image closes without deactivating. It eats up an activation that you need to get reset. But with activation keys, it's smarter about it, and it deactivates itself when the Docker container goes down. So that's really important. So then how do the users get in? How do they get access to these software services? Well, you first have your network access security. Can they even get into the network? And that is not something that's not, all right. That wasn't something that we did. We are now doing a build out of a network for a county health agency where we are building like a separate network that's ours and attaching it to their network. So all of a sudden we become responsible for the perimeter security. Normally that's not our problem, but now it is. But now we need proper authentication integration. Now, usually the customer is using some sort of authentication provider, Active Directory, which I'll get to. I'll get to in a little bit. But we need to make sure that they provide us the right information for their authentication, whether they are using multi-factor authentication, and their HTTPS connections need SSL certs, and that needs a certificate authority. So we're going to walk through each of these. So authentication, which is access control based on usernames. And that's usually done through Active Directory, which is Entra ID now on Azure, SAML, Okta, or OAuth. And also Keycloak is one we've seen a lot of. That's really popular, and Authentic is becoming more popular. And so we need to make sure that customers give us the proper information, which they almost never do. They almost never give us the proper Active Directory information, and I get why. They don't want to give that out to anybody. That's access to their whole authentication. You don't want that hacked. But at some point, we need access to it so their machines can authenticate. And they'll often have databases holding their precious data, like that IRS database, which oftentimes have both individual row and cell level permissioning. And we need to be able to communicate with the database. And some of those best practices are definitely making sure you store all of your secrets, at least in environment variables, if not in proper key stores. Like Bitbucket has a secret storage system, and so does AWS and Azure and all of them. You really want to use a service account if you're using a database or storage or an API, because what happens to the person connecting to the database? They built an app, but they leave the agency and the app no longer works. We see this happen all the time. We get a panic call, the app no longer works. And the first question is, did someone leave the agency? And if they do, you need to change your credentials. And oftentimes you'll see they want to use Kerberos to pass through system credentials to the database, but that causes all sorts of issues. We actually discourage it. But then you have to secure the actual content in something like RStudio Connect. You might have Shiny apps or Flask apps or Plumber APIs. And for that, there's multiple layers. Only people on your network could get to the Connect server in the first place. And then Connect has, at each individual piece of content, you could say which individual people can access it or which groups of people can access it. And that can be tied into your identity provider, like Active Directory. You can set the groups there and say, admins can see this apps, users can see these apps, analysts can see these other apps. So there's a lot we needed to consider, all these different things. I know I didn't tell you the answers for everything, and that's because each situation, the answers are different. I wanted to give you a taste of what we consider and what we work with and how we go about it. Because every customer that gives different situations, it's a different environment. So what should we focus on? Well, first is the type of environment, whether it's bare metal, an on-premises VM, a cloud VM, or Kubernetes. How locked down is it? Is it a public access network, a private network, or is it air gapped? You have to think about, how do you move files onto the network? Do you use SSH tunnels? Do you use a sneaker net? How are you going to handle HTTPS and SSL certs? It is so much harder than you realize. This can delay a project by months if you don't have the certs set up correctly. And you can't use self-signed certs. They need to be signed by proper certificate authority. And authentication. This is also incredibly hard. This will also kill months of time. This causes more issues than anything else, because getting the authentication provider to communicate to your software, do you have the proper credentials? And let me tell you, there's almost never the proper credentials. Is there network access between the computer you're on and the authentication provider? There's all sorts of fun issues with that. But if you do all of this and you do it all in the right order, then you're all set and you're done. And you can start using the code. And that's where we come in. We come in and be like, I would love to do more projects that are just data analysis, I would love to be able to go do more analysis, build more maps, fit more machine learning pipelines, do more data manipulation, build reports. But a lot of people benefit a lot from our ability to set up their environments so they can go get R in their secure system and do their work. So while we might not be doing the data science work in that case, we're enabling the data scientists and the statisticians to do their work. And that's really nice too. So thank you for coming. I hope this was insightful for you.
Thank you, Jared. I don't see any questions in the Q&A or the chat. Everybody's being remarkably quiet. I'll give folks a chance to chime in. But let me ask you a question about the authentication. Those options that you mentioned, are they commercial?
Oh yeah, well, so almost everything. So almost all of them are commercial to various degrees. So Active Directory is Microsoft's thing, and almost everybody's using Microsoft authentication. Even customers on AWS using Microsoft authentication. Now, SAML is a open, I guess, I don't want to say open interface, an open standard that allows communication between Active Directory or Okta. Okta is another commercial one as an identity provider. Keycloak is open source, and I do see people use it more and more on the defense side, but I haven't seen it too much in the corporate world or other parts of the government. Now, OAuth or OAuth 2 is open source, but that's meant to facilitate the communication between your identity provider, which is usually Keycloak or Active Directory or Okta or Google Identity, right? So the communication protocols like SAML and OAuth 2 are open source, and most of the identity providers are closed, like Okta and Active Directory, except for Keycloak and Authentic are open.
Yeah, that's always I guess a consideration of mine for what it's worth. But and even though something is open source, it's not always free in terms of work hours and that type of thing, which you've brought up
Bill
several
versus buy
times.
matters.
Yeah, which I think is important, right? Because there's always this cost in man hours, person hours.
And then is also the cost in, while I fully believe in the security of Keycloak, if the users are, well, first of all, the client's already using Active Directory, they were done. But also there's certain things that I feel comfortable in, and that's setting up the R environment. But identity management, maybe my company specialized in that, but since I don't, I'm going to use an off-the-shelf solution that's ready to go. That said, though, we are setting up Keycloak internally to mirror what one of our customers had, so we are comfortable with it, but that's not our bread and butter.
And in our meeting with not our govies, but the interagency our users group, you talked about different situations that you had to deal with roadblocks and that type of thing. I don't know the right question, but one thing it seems that I tend to do or whatever is that I encounter maybe a problem and or a hurdle or something, a roadblock, and try not to let that stop me. I have to find a detour or some other way to make it happen. And I think you mentioned some examples like that before, but could you just say a little, I mean, you don't have to give us examples, but could you just say anything about like to motivate people in that respect that, uh,
Yeah, so a lot of these roadblocks are created. Well, some roadblocks are created because some people are intransigent, but most of them are created because something bad happened one time and people want to make sure it doesn't happen again. And that usually people will want to work with you to enable you, and but they also don't necessarily want to go out of their way. Like if you can figure it out, then sure they'll go with it. We had I'll give you an example. We had package manager. We are trying to get like an authority to operate, and package manager, they couldn't find any proof that that was used on a secure network anywhere, and they said you can't have it. But then I did some research and said, hey, look, the NSA makes it available to people. Surely if they do it, that means we can use it because this was at a defense agency. And they said, okay, NSA has it on the high side network. That's proof. Thank you. And they allowed it to happen. So sometimes it's a matter of reaching out to a higher authority to say that it'll get done. There's another method which I don't like as much, but I know people use. Again, this again goes to the military, that if there is like a 4-star general who says they want this, they get it. But that runs roughshod over people, and that's not good because then all of a sudden the person just got, slammed by a 4-star general, and that doesn't make them feel good. And they're not going to want to work with you in the future. So you gotta, you don't want to use all of you don't want to point a gun at someone if you don't need to.
yeah, and maybe this is, a bit heretical, but I guess, or blasphemy, but just because the general or the admiral says to do it doesn't mean it's necessary. A good thing,
That too.
to do. Hey, we have a question.
That's great.
Um, what was the name of the capability, that you described where you were able to transfer an image from Nipper to JWix?
So
Was
that
that Clear, CLEAR?
Oh, I've used Clear, I see Clear, and I'm not, and it's clunky. So there's actually two services that are related to each other. For moving the images, on JWix, there's something called, I'm trying to, yeah, make sure I can say it, sorry. It's a JWix system called Container Yard. And Container Yard, it's literally for container, it's like meant to like a shipping container yard. And it has access to container registries from so many different registries. There's Docker Hub, like I said, there's Quay.io, which should be pronounced Key.io, but they call it Quay.io. There's GitHub Container Registry, Azure, all that stuff. And they have, I believe, ServiceNow. It's like a ticket. Literally, you have to put in a ticket. The ticket I created was, can you please move Docker Hub, hub.docker.com/jaredlander/RML to the high side. That's it. It was a sentence. And they said, sure, and 2 hours later it was there. So that's Container Yard. For moving other stuff, like if you want to mirror an entire GitHub repo or an S3 bucket, that's called Portkey. And there you go into GitLab and you put in an issue, a ticket saying, please mirror this GitHub repository or this S3 bucket. And they were slammed, so it didn't get done until the next day. Right? And one day, it took one day, and now it's updated on a semi-weekly basis automatically. So I make a change on the low side, it's automatically on the high side. So that's magical, right? Now, we're working with another agency, not defense, a financial regulator. They don't have this service, but luckily there, we can move it to the internet connected. The internet connected machine can pull from Docker Hub, and that machine can SCP it to their local registry, to the local other computers. So but that service, Portkey and Container Yard, they're going to be your two. You're going to love those.
Oh, good. He said, thank you. Yeah, things have certainly changed. And technology, security, it's always changing and advancing. So that's one of the things when you were talking about authentication, that this was with a school that I'm going to, but they had this one authentication thing, which I liked. And then they moved to the Microsoft Authenticator, which I don't like.
Yeah.
So,
Yeah, then you do have all this 2FA stuff, like for what's it called? For this financial regulator, we have to log into their networks, and we could use the Microsoft Authenticator on our phones. And that's fine and dandy. But for defense, we can't bring our phones in. So we have those little tokens we have to carry around, which God forbid you show up without that. So
yeah, I didn't, I mean, you mentioned that in your talk, but I didn't pick up on it.
yeah.
But yeah, that's true that you kind of depend on, oh, here's this app or whatever it is on your phone, but if you can't take it in with you, then
Yeah.
it's not very useful.
then it gets tricky. Let's say I want to sign in, like there's sometimes there's the skiffs that let you like log into your corporate email, right? But my corporate email has 2FA. So I need to log in, run outside to wherever my phone is, get the 2FA and go running back in, um, which is not always feasible.
But it's a good thing that there's different ways to get to the end result, which is why I was kind of mentioning the roadblock thing that to keep
Oh,
trying options. And
here's another thing that surprised me. Both within the DoD and within financial regulators and some other agencies, I've been amazed at how good their like 1-800 helplines are. I've called a number of helplines, and they're the most helpful helplines I've ever had in my life. One time, I'm even talking about like an invoicing helpline. I had to submit an invoice and I had never done it before. I got someone out in Utah and they spent 45 minutes very carefully and nicely walking me through how to submit an invoice. Then I had a different helpline I needed to get to, use it was actually a physical token I had, not the RSA token, but like a physical token, and called a helpline. They walked me through what I had to do on my computer and what to do. So as far as I've experienced, the US government has great tech support helplines. So call them. They're great.
well, that is a good not advertisement, but endorsement. I don't know the right word.
Yeah. Yeah.
For the governments, which you don't often hear, right? So
Mhm. And then
thank you for that.
and the opposite is I relayed a anecdote at the interagency the IUG, right? The IUG. My wife works at a government agency, and they theoretically have our studio workbench, but they can't get anyone to install it, and so it's sitting there unused. And this actually sort of puts faith in, drops faith, but puts faith also. My company, we install our studio workbench for government agencies. They won't let us do it though because it's a conflict because I'm married to her. So on one hand, great that no corruption's allowed. On the other hand, it'd be nice if she had that installed.
Yes, there's always these little gotchas.
Yeah. Yeah. But it's nice that, they want to make sure everything's above board, which it would have been because, we would charge the same rate we charge anybody else, but I get why they have to be careful.
Yeah, maybe you could teach your wife how to do it.
Yeah, teacher, and then she has to come work for me afterwards.
Exactly.
That said, if anyone needs this installed, contact me. We can install it for you. We've done it on various government networks.
Yes, and you got Jared's uh website, and also there's the October, I think that's why I kept thinking we were in October, but the October conference, right? The end of
Yes. Yes, actually, so I want to say, thank you for reminding me. We have the R in government, R and Friends in government. There will be other talks there. The R in government and public sector conference coming up October 20th through 30th. The 20th is workshops. The 20th and 30th are talks, 20-minute talks. It's at Georgetown and it's virtual. If you go to rstats.ai/gov, you can get tickets. And if you're a member of this group, we have a discount code called RGOVIES20, like RGOVYS20. And if you use that, you'll get a 20% discount on either an in-person or a virtual ticket. And you can come attend and have a great time. It's really a great conference, and we have a lot of great content. We have speakers this year from the Securities and Exchange Commission, from the FDA. We have speakers from, I believe, someone in the Army. I think maybe someone from the Air Force. We have someone from
census.
But yeah, we have a census. Thanks to you, Wendy. We have a census speaker. We have maybe a fisheries talk, like an NOAA fisheries, maybe. It's all over the government. Yeah.
You have somebody from NASA,
We have 2 NASA speakers this year.
yeah, I keep forgetting his name from NASA, but he's fantastic.
There's
He's
David
there.
Meza, you might be thinking
Yeah,
of.
yeah. He was sort of our advocate
Mhm.
before, I mean, from a long time, our advocate, I'll put it that
Yep.
way.
We have David, we have people outside
Yeah.
the government giving talks. We have people, I think we have someone like, we definitely have people like just like NGOs giving talks. So we have contractors there giving talks. It's going to be a broad mix of topics, and it ranges from how to use an LLM in a secure network to how to authenticate against the identity provider to, I think mine's going to be talking about mapping. I do a lot of mapping now, so I'm going to talk about how to do 4 million points on an interactive map. So lots of fun, lots of topical conversations.
Well, I'm registered and I'm looking forward to it. So,
Looking forward to seeing you virtually at least.
all right, sounds good. All right, we're gonna have to meet in person one day.
Yes, that would be nice.
All right, well, thank you so much, Jared. I really appreciate your time with the users group and the RGovies and all that you're doing for R and for the government. So thank you very much. Here's some applause.
Thank you very much.
And thanks everybody on the webinar, and keep an eye out for future meetings.
Great.
All right.
Thanks,
Thanks,
folks.
Jared. Thanks, everybody.
Bye.
Bye.